All right, everyone. Hopefully, if people are listening, could you put something in the chat down, wherever your chat ends up being, so that we're all on the same page, or I know that at least somebody is listening to what's going on here. I'm going to keep things somewhat simple for right now. We could definitely do a Zoom meeting. Hey, they're all right. Thank you. That should be enough. We have people listening. So my question is, what do you really want to go over? I know that there are concerns right now about assignment one, and I'm going to try and find the best way, because right now, if I have a large number of people for this, then I want to record a live stream rather than try and do like a Zoom meeting. If I do a Zoom meeting, it's going to be everyone just muted anyways, and just me presenting as a live stream anyway, so it's the same thing. This will be recorded at least. So I'm willing to change up how we do our synchronous time together. I just want to make sure that you have some time that you can work, that we can all work together on particular problems that you're struggling with, or that you want help with. All right, so we got some streams here. All right, so I think the first thing that let me rephrase things here. I think the first thing that we want to go over, and correct me if I'm wrong, or don't because you're muted, is that we want to look at assignment one. Assignment one is going to come up in weird, wonderful ways, and if you haven't looked at it yet, look at it now, I guess, or look at it soon. Assignment one is designed to make sure that you're applying what we learned in 1400, and if you don't remember parts of 1400, then we need to sort of fix that. And if you do remember 1400, it shouldn't be impossibly hard, but there's still some challenges in there. What I would like to point out is what this thing is actually doing. Let's see if I have a nice PowerPoint slide for this. Statistic, data collection, how to give a presentation. No, I'm going to open up, let's see if I can open up my linked list presentation thing. Browse. Okay. 2400. And lectures. There we go. Linked lists. The reason I'm bringing up linked lists is that they are going to be, and their video is already up online, is that linked lists are going to look remarkably similar to trees. And so I'm going to just throw something else up here. Let's also make a brand new thing. Trees. All right. And let's present here. Here's what we're doing with trees. What we had, the very concept that we're dealing with. What I will make is a tree node, and I'll have a pointer to a tree node. So if I have a pointer to a tree node, this pointer is pointing to this thing here. This is my tree node. The tree node itself has pointers to other tree nodes. And so this is pointer child 1. Child 2. And this thing could have pointers to pointers. And this thing could have pointers to pointers. The idea behind a tree is that at any given time I can string together a whole bunch of these nodes. There's no upper limit like there is in an array. If I have an array and and I run out of space, oh crap, I run out of space. If I just keep on producing tree nodes and then just hooking them up, there is no actual upper limit other than my memory size to how big this thing can be. So if I make a tree node structure, and then that points to other tree node structures, which then point to other tree node structures, I can just keep on doing this. So my tree node structure can have pointers to other tree nodes. That's the big takeaway that a lot of people get confused by. So I'm also, let's see if I can do this for linked lists. So a linked list, I'm going to go back one slide here. A linked list here is, instead of being like this, let's do a linked list. So here's my linked list. I have a linked list node, which then points to another linked list node, which then points to another linked list node. How do I know when I stopped? This thing at the end will be, no, I'm pointing to nothing here, right? All the other ones point to the next thing in the row, like a train. It's just a series of parts all connected one to the other. The very first node in my the very first linked list node that I have, it's a data structure. So let's make a struct, and I have that live code already done. Let's call it LL node. It's going to look something like this. So this is the blueprint. This is what a linked list node will look like. It is one of these data structures. And so let's put some numbers on this, like 1, 4, 17. Let's put some numbers on this one. 1, 5. Let's make different numbers. 2, 5, 9, 3, -1, 97, 11. Right. You can put anything you want on these things. Right now, what we're going to be doing is we're going to store in some integer. It could be anything. It could be a string. It could be some other thing. It's just some kind of package of data that's being in there. This thing is wrapping up a package of data and where it's pointing to next. So here is, I'm going to just clear up my linked list here. I'm going to have some integer, let's see, call it an ID, that's fine. And then I'm going to have a pointer to another linked list node. It's a pointer, and let's just call it next. It is the next linked list node. So if I take any linked list node, I could get the next one, and the next one, and the next one, and the next one, over and over again. The reason I'm pointing out linked lists and not trees is because they should be about the same in terms of how I go about solving this problem. That's why I wanted to make sure I was we're pointing this out again. A linked list has what's next, the next thing in the chain. And when this next is finally null, I know I'm at the end of my linked list. So I start off here. If I go to the next one, I go here. If I get the next one, I go here. If I go to the next one, I go here, and I'm done. That is what a linked list does, and we'll do something very similar with a tree. If I wanted to hook up node 1 to node 5, I would say tree, like whatever my current tree node is, cur tree node dot child1 is equal to, and I give the pointer to this node itself. I can just directly hook up where everything is pointing to. So this is the idea that I'm trying to play around with, at least for right now. I'm going to show you some live code of the tree nodes in the linked lists, in a second. That code is already available. It's already in the presentations, but I want to just double check to see what you guys have for chat questions, if there's any chat questions so far, just to make sure I'm not talking about something that's not confusing you guys. So if you have problems with compiling or how to do various things, I'm more than happy to go over that instead. And let's get some feedback at the end of this to see if you'd prefer a more interactive thing like with Zoom or versus a live stream. So let's keep this. We're going to keep that slide here, and let's see what we have here in our thing. So, oh, you're right. Well, thank you. I'm glad I checked rather than going off into the deep end with bit 2400. So, yes, thank you. I very much appreciate it. I teach too many classes. I just taught a grad seminar just now. So, okay. No need to panic. The question is, what are you panicking about? Is there something about Scratch that? So I gotta switch up here. Soup. Is there something about Scratch here that you want to make sure we cover? Is there something about setting up Visual Studio you want us to cover, or just doing a Hello World project? Oh, I'm so embarrassed. Oh God. Okay. Can I help anybody? Is there a particular topic you really want to make sure that I go over for 1400, not 2400? It didn't show up, by the way, when you did that. So, okay. A brief walkthrough of the Visual Studio. Absolutely. Pseudocode getting at least five numbers. Okay. And do we need comments in your code? Absolutely. When you finally start coding, you can't do it in Scratch, but I definitely want comments. Work for the link to Scratch. Yes, the SP3 file does work for Scratch once you once you save the file, but you should still make sure you have instructions in your Scratch file. Visual Studio. Okay, there's too much stuff. Too original. No, Scratch thing does not have to be too original, but don't give me Pong. Yes, SP3 thing. Scratch problems. Two separate Scratch games that you need to make the lab. So okay, let me see. I want to make sure. Yeah, no, we're not doing AI. Okay, the logic of your game is different than the AI. So let's break this down to a couple of chunks here. Number one, when it comes to the Scratch game, it does not have to be original. It does not have to be brand new that no one's ever seen this thing before. It does not have to be some kind of magical thing. So if you let's see if I have my Scratch. Scratch. There's Duck Pong. That's my project here. Hopefully I'm logged in. Oh, that's because I'm not signed in. Is it going to be using Beastbreak 18? Yes, this is my kid's account. Nope. There we go. All right. So here is Duck Pong. This is something I just made quickly. Let's see inside. Notice this is the Pong game. You cannot submit that for the assignment. So some of the questions that we had were, do we have to do the labs and the assignment? The labs are for you. Let's be very clear about that. You pass in the lab because you want to pass in the lab. And well, we have mandatory marks on it, but whether your lab works, whether your lab you only got halfway through the lab, or whatever the case is, that's fine. The lab is the practice everyone needs when they're learning to code. That's what the labs are for. That's all the labs are for. I used to have them be worth 0 points, and then no one showed up to the labs. And then I realized you have to put some points in there, but I don't want to make it so that oh, you didn't do all parts of the lab, oh, you get 0, right? It's meant to be getting comfortable. It's your excuse to practice something out, fail miserably. That's great if you fail miserably, right? Especially if you learn from it. Try something out, see if it works, and go from there, right? Try something, and oh, that's not how you make an array. Oh, I'm going to do something different. And what we're going to try and do, I think Janae is going to be your head lab TA. Janae is going to try and be on call whenever you guys have your labs officially scheduled. I have to follow up on that. When Janae goes, so when you have your lab time, you can do your lab, and if you have any questions, you can contact Janae. He's also going to make videos for how to do the labs themselves. The assignment itself, you'll save a copy, save now, save to your computer, and you will make you got an SP3 file, and that's good enough. You submit that, you're fine. Notice, however, that some of these things, like the background, let's make another backdrop. Costume sounds, code. Let's see, can I make a new backdrop? Or is that, no, that's a costume. I want another backdrop. Or I could just do this one. Oh, I want another stage. There we go. So I can make another stage, let's say, or and then what I could do is paint and say, that's really ugly, but you can also upload, I think, you could put your instructions straight on there. I think you can actually even type in your instructions if you need to. There you go. Okay. Hello world. How are you? The instructions are A, B, and C. Right. You could put some set of instructions in there, let's say. So let's put that in, make that black. Will that work? Yeah, there you go. You could put your instructions as a load screen, initial screen that you show up, and then after a certain amount of time, that goes away, right? So that you can tell someone what the instructions are for the game, for example. You can also put it, if you make a project and you save it online, you can just share the URL to your project itself. You need some way of conveying to the TAs what your instructions are. That's the thing that actually has to work. Your Scratch game actually has to work. It does not have to be overly original. Something as simple as what we had, Dino Dinner, or whatever the name of the file was, that would be perfectly fine. So let's see, my stuff. Can I save it? No, let's just save it there first. Save now. My stuff. And so Blueberry and Orange's Adventure would be fine. We'll do something maybe a bit different. Here is Dino Dinner, which is you eating ballerinas as they go across the screen. You could do all sorts of different things. They've tried a whole bunch of different things. We have Frog Hopper. We have a polar bear game that they made. Right? You can do whatever you want with this. The idea is that you can play with it, and I mean, you don't go overly complex, but you certainly don't need AI for this thing. That is its whole other course all on its own. A proper AI system is very, very difficult to make, and you cannot do it in Scratch. You do need some logic, as in, if the enemy goes and touches you, then you eat the character. That would be fine, but it's not necessarily an AI per se. Have PDF under the instructions. Yep, that should be fine too. Yep, sure. Well, this stuff has gone over the instructions, but people still ask me anyways. To save my Scratch game, my computer won't let me open the file. Is there any troubleshooting I can do to fix this? I would have to look at that myself. I don't know. You should be able to. I would save it out again and then look at. Then make sure you're downloading the file and make sure it's going to a writable directory. But it should have gone. Should have been fine. Yes, and for the assignments or the labs themselves, whatever works for you. Just yeah. Do we have class today? Lab class today? No, not really. I don't think. You just want to make sure that your labs themselves are for you to practice. Okay. The other questions, people wanted to see Visual Studio in action, so let's hopefully not give away I'm giving away answers to another course. That's nice to see. So let's make a brand new project if you want to see Visual Studio in action. I have downloaded Visual Studio. You'll notice if I go to my About Visual Register product. In case you have not done this, you will need to make sure you add your Carlton, I think it's your CMail account here. It has to be something to do with a STEM program. So you can add, I normally add it to all accounts, not this personalized account, but this one down here. You add the account in all accounts, and then you, with your CMail account, and then you can actually just get Visual Studio. But notice I'm using Visual Studio Community, not Enterprise. If you use Enterprise, it's going to go away after a couple of months, and you'll be really crabby like I was when it went away a couple of months later. So Visual Studio Community, it doesn't expire the way that Enterprise will. Okay, let's see here. I have a big flow of data that went by here. So let's make a brand new project. We're going to see this in action very, very soon. I always make empty projects. There are Hello World projects that you can put in there, or a console app. But this will print Hello World, but it gives you a bunch of extra cruft that you didn't need. So I normally have a C++ project. Make sure it's C++ up here. And then I say an empty project, and I go next. And let's move this around. And I'm going to go to 1400 and there. Class code, and we're going to do let's make a brand, let's just save it there. Sync hello world. So for the Synchronous class, making a hello world project, I'm making it a brand new solution, and the solution's name, I don't want that. Oh, I don't want this actually. I want this thing over here. There we go. All right, let's create it and let's see what we have here. It's going to make a brand new project. It's going to have Jack Squad in it. All right. I'm going to now make a brand new file. So this is me having a synchronized folder. So I'm going to add a new item, and that's going to be a CPP file. And it's not going to be called source because that's a crappy name. Sync hello world.cpp. Okay. We'll be looking at that soon enough. And I don't think I have a semicolon. I always forget. Int main. All right. So I need a semicolon. There you go. That should fix its wagon. All right, let's save it and see what happens. Print F. Oh, yeah, printf, constant character format. Okay. Yes. Should know this by now, but I didn't eat lunch yet. All right, so I'm going to save it. Notice what happened when I didn't have that. I'm a very messy programmer. I constantly will forget a semicolon. I'll forget something or other in there, and something like print. If I see an underline, I go whoa, 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 whoa. I typed something wrong in here. If I forget my quotes, for example, the colors are going to be wrong. I get an underline here. All this is going to do is put this text message out to the screen. That's all printf does. We are just doing the absolute bare minimum function to actually test that C is working. So what I'm going to do is I'm going to go to my build. I'm going to build solution, Control-Shift-B. There's a hotkey for it. I will do the hotkey a whole bunch of times, but you should, see what I'm doing, and before I just assume that you know what the hotkey is. Control-Shift-B will build this thing. I build it. I hope everything builds correctly. So I'm going to build my file. 1 succeeded, 0 failed. Okay. Notice I did not just press the play button. I like to point this out, despite the fact that some people go, well, I've already done this before. Yeah, I have a bunch of 2400 students freaking out right now because they can't figure out their bug because they were just pressing the play button each time, which builds then runs, one after the other. If you build and run at the same time, what happens? If you build and run at the same time and it doesn't build correctly, that is the part of making your program before you run it. If it doesn't build correctly, it will try and run whatever old version you had. So you'll be testing out a program that is not the one you currently have. It is like doing the assignment from the previous term versus the current term. It is not the right thing in this case. So I normally take these in 2 separate steps. I build separately so that I can make sure that it built correctly, and then I execute. I then press the play button. So we're going to press the play button, and we should see hello world pop up on the screen. Boom. Hello world, and that's everything. Okay. That is Visual Studio. That's what you're going to need for Visual Studio for the first little while. So that is about as walkthrough as we need to necessarily get with setting up a brand new project. Later on, we're going to be taking inputs, we're going to make variables, but those are for later assignments. There was a question about pseudocode that I would like to jump on as well. So let's see. What is is less than someone asked. L3, I have no idea. The assignment, by the way, this assignment is on Scratch. Later on, I was told to show Visual Studio in action. So this is me showing Visual Studio. And yes, for standard library, STD is not sexually transmitted disease, although I snicker under my breath each time as well. So STD is the library you use to build functions in the classes. No, so let me go over what that thing is. This thing right here is, so I don't even think I need it. Let's find out. Ultimate Arbiter. Didn't need it this time. We will need it if we go to, and so we can actually get rid of that. I've been putting it in out of force of habit for this reason. So let's do this, and here is the same program using C++. I probably should use the same capitalization, but and there you go. Same program. This is C++ code, the thing you're not supposed to be using for this term. It is C++ code because it looks, the reason why you're not allowed to use it for this term is that it looks like nothing else that you do in straight C. Printf is what C looks like. Cout, what is this cout thing? It's actually an object, and what's an object? Oh crap, now you're in 2400. And we've already realized that we're not supposed to be doing 2400. We learned that the first 5 minutes of this seminar, or synchronization. So the using namespace standard was for that, and I've just gotten into a really bad habit of always putting it in there. The reason, oh, let me put it back in for 2 seconds. The reason you need that is the following. And compile, there you go. That's why you needed it. Because otherwise you need to do this. You need to say, where's the cout thing found? Oh, it's in the standard namespace. Where is this endl thing found? Oh, it's in the standard namespace. It's not needed for this particular case, so let's just comment this out and we'll put back in my printf statement. This is C++ code. This is C. There is a difference between the two, and I'm sure you're probably all aware that there's a difference between the two. C++ code is sort of like taking C and then adding a whole lot of other stuff on top of it. It adds objects, and we will get to C++, but we're getting it to it in bit 2400. So that's the original reason for this. Okay, let's see what other comments. Oh my god, there's so many comments. We're doing C. Yes, we're doing straight C. No marks or attendance are done here. Okay, yeah. So you don't have to be here if you don't want to. Yes, and Zane. Yes, C++ is object oriented and C isn't, but C++ builds on top of C, and so it keeps all the syntax. And you can actually, if you have a C++ program, you can write it as straight C, and that's actually leading to all sorts of little weird quirks. That most programmers, myself included when I started, don't know the difference between C, where the line is. They don't know where C ends and where C++ begins. So they'll use cout instead of using printf in what they think is a pure C program. And I wanted to keep them completely separate. So, okay. And can I see what other things... labs are pre-recorded. The labs are just a little mini pre-recorded just to get you started, and then you go from there. I really wish we could have TAs or myself in the lab working with you, right around you, to help you when you get stuck on things, because it's little tiny things that are huge for you, but they're little tiny things. So things like, let's see if I have another example of this. Things like the following. There you go. This will cause all sorts of heartaches, and then you'll go printf, what's going on? Question marks, I should say. Okay, right? Why is this suddenly indented? Why is there an underline here? And 90% of the problems that you get in 1400 are that. That semicolon indicates the end of a line. C doesn't use the carriage return, you putting it on a new line. It uses that semicolon to indicate the end of the line. That way you can do things like this, and it's the same code as that, right? That's what you sort of want, is you don't want, if you add an extra white space, it doesn't break your code. If I leave off the semicolon, tells me that the end of the line is there, and it's the most common mistake that people make when they're learning to program. They'll go and compile, and then they'll say, first of all, people will write all their code all at once and then compile and see if it works. And it's the kiss of death, because they will have 300 lines of code, and they'll be like, something's broken. What's broken? I don't know. And they just throw their hands in the air and just freak out. So this is why I want you to work through this in the labs. If we can't do that, I would like to have chats with you guys about what you're getting stuck on. Okay, so no actual new comments. That's Good. Okay. So we've looked at a very, very basic C program. I will also say with that basic C program, that get used to making small little programs, testing it, and building from there, not just trying to write all your code all at once. And people will ignore that particular piece of advice and try to write all their code all at once the night before the exam is due or the assignment is due. You shouldn't need SID, you shouldn't need MFC for this term. You'll need it in 2400. It is built into C++ or Visual Studio, so you could just grab it as an extra package. Java and C are different languages. It's like English and French. They are not compatible languages necessarily. You speak one or the other. You don't speak, unless you're from certain areas of Quebec, you don't speak the combination of the two at once. And so the Pong Scratch project is due Wednesday. There's nothing due for the labs. It is purely for you practicing, but you submit something. But there's no hard deadline on that one. There's hard deadlines in the assignments. Java Eclipse won't really work at all. And really, just learning another language and learning another IDE. I know that I've had so many students where they push back against learning a new language, and it's perfectly normal. I do it too. But at the same time, it's learning a new language. It's not like learning an actual spoken language, which takes years and years and years and years to get passably good at. It's a tool in your toolbox. And as a result, if you have this tool in your toolbox, if I know Java and I know C++ and I know Python and I know JavaScript and I know all these other languages, I can figure out the right tool for the job. And that's ideally what we're looking for. We're not looking for you to be expert programmers in C. We're looking for you to be good enough programmers in C and good enough programmers in C++, get into industry, and then figure out what language you need. But you've learned the basics, and if you know C and you know how to program in C, you know how to program in most procedural languages. If you know C++, you know how to program in most object-oriented languages. And then if you learn, so you learn C++, and then when you get introduced to Java, you go, oh, I know what that looks like. It looks like this. Much like if you learn French, you can sort of use some of the grammar and the rules to apply to English. Or or better yet, if you learn French, a lot easier to move to Spanish, for example. Pronunciation is different, but that's the case. Yeah, and you can really like Java, Logan, but that's my first language. That's what I learned in university. One of my old professors used to say, if you want to write something quickly, write it in Java. If you want to write it well, write it in C++. And that's not necessarily true, but C++ is, if you're making a video game, you do it in C++ for the most part, or at least traditionally you did, because it's way more efficient in terms of code efficiency. It's are we using Arduinos? No, we're not using it this term because I don't know how to write anything in Arduinos. That would be C, but when you're using C, if you have a C compiler, for example, if you learn C, that then goes, I do believe the Arduino's compiler is a C compiler. So any of your code you write using for these on-chip boards that you would have, like your Raspberry Pis, if I have my Raspberry Pi here. There is my Raspberry Pi. There we go. Do I have a camera here? Oh, it's going to delay it for a bit. If you're learning how to... Wow, that delay is so long. There you go. Here's my Raspberry Pi thing. If you were learning how to do something on a single chip, on one of these embedded, one of these small little miniature computers, there's limited resources for them, and so therefore you do something like C, not something that's a heavyweight language necessarily. And so we're not doing that this term, but what you learn in 1400 will be applicable there too. Okay. So let me see if there's... How many people have actually done... maybe just say a yes or a no, maybe. How many people have actually have looked at pseudocode? And if I want to figure out if there's any issues or problems with pseudocode or flowcharts, that sort of thing. That's sort of the next thing on the horizon, that's all. All right. A lot of people. No, okay, yes, no, yes, no. Okay. You guys are all the keeners of the group. Uh, okay, so then the question is, what do you want to do? Is there any interest in me going over pseudocode, or is this all just making sense and it's pretty obvious? The difference between rectangles and other square shapes. So another square shape. There's a rounded shape, so for the start and end. There's a diamond for conditional. There is a rectangle for an action. I didn't think we were doing other things, maybe variables as well. Trapezoid. There's a trapezoid. Yes, that's user input. Yeah. So trapezoid would normally be sure. Trapezoid, yes, please. Okay. 90. Okay. I have no idea what 90 means, but okay. So many things. Hold on one second. I want to find out what other people say. I couldn't get the pseudocode to get the least 5 numbers on a list. Yeah, that was the one's nasty. Okay, and what is pseudocode? Thank you, Vincent. All right, so let's go over what we're doing here. So let's make a brand new one. I'm gonna have to like move stuff over. So let's have a look at pseudocode. So pseudocode is going to be effectively this way. We're going to have some kind of start. I should move this around. And all you were doing is following from one thing to another. This should be input from the user. There should be some kind of action that the user is you're taking. For example, you are taking the average of a bunch of numbers, or you are adding 2 numbers together. We have conditionals. Oh, maybe I should use true or false here. And then some end state. So I've actually just shown all the various parts of the plumbing here for a flowchart. Now this is, and the R in start looks terrible, but okay. The idea is I have a start and an end state that is using a circle just to indicate it. That is just purely by convention. It's not because, oh, that circle means so much, just convention. We also have, and I'm hoping it's a parallelogram, but is it? I think it's a parallelogram. If it's trapezoid, then it's a trapezoid, but it's one of those things that doesn't come up that often. You're getting user input. So things like, give me the next number in the set of numbers that we're collecting. The reason I don't put that in there, and the reason I don't remember it necessarily, is because what I'm going to be trying to do for the next number of classes is get your heads out of the space of every function or every algorithm, every subroutine that you make needs user input. The vast majority of algorithms you're ever going to write do not take user input. They come in with some value. You do some action. Right? Your video game doesn't check for the user type pushing something on the game controller to draw something on the screen, or check something on what the person did on the game controller to figure out what the AI is doing next. The AI is getting some information from the game, and it's calculating what it needs to calculate there based on the state of the game, not based on the user input. And so input itself is a bit of a rarity. The actions themselves, the rectangular actions, are just every step you're going to take is an action. Okay, and then we have a conditional, which is if this is true, then do this. If this is false, then do this. I can branch it in multiple different ways. Notice with this, especially with conditional, I can actually make a loop. This has a loop structure right now. I go down to this conditional, and I go right back up here, and I go back through the action and check the conditional again. To go back up here and check the action, do the action, check the conditional again. And by doing this, there's no official, like, this is the right way of doing a flowchart. The right way to do a flowchart is, does it make sense? Do other people understand what you're doing? Did you break down the problem into small, manageable chunks? That's what correct is. We still want you to use these kind of symbol sets, but it's not meant to be draconian in how we evaluate your flowcharts. Same thing with pseudocode. Pseudocode is any amount of English-like, or not even English-like, but any kind of non-code. It can look sort of like program code, but it doesn't have to. But it is, can I break a big, nasty problem into a series of non-ambiguous steps? Every one of those non-ambiguous steps is part of your pseudocode. So it might be, let me see here. We can put numbers on it if we need to. Something like that, right? It's whatever works for you to get your head around the problem. That's all it is. It's not meant for me. It's actually not meant for anyone else at all. But it's something that we have to emphasize because people keep on forgetting that it's important. So what we'll end up getting in this class at the end of the day is I will ask you to do some kind of function. I will ask you to write some kind of code, and we'll get to the 5 numbers thing in a second. I will ask you to write some kind of code, and a chunk of you will just start typing code into the computer. You'll just start typing code and hope for the best. And I literally told my wife this, and she's a computer engineer as well. And she was like, well, that's stupid. She's not the most subtle person in the world. Right? That's stupid. Why would you ever do that? You should be writing things down on paper first. Like, yes, I know. I'm trying to tell them to write things on paper first. Oh my God, why would you not write things on paper first? She takes it one step further. She writes it on paper, codes it, realizes the things that she missed with her code, and then rewrites all the code all over again. She does a 2-batch process with her coding. She doesn't have bugs in her code, but I'm not that patient. Your job is to break down the problem first before you code. Much like your job, if you're an artist, you don't just break out the oil paints and start painting. You doodle what your painting is going to be first, and then you paint it out afterwards. Every artist does multiple iterations of the same thing, or they do drafts of what they're going to be drawing. If you're doing math proof, you doodle something out first, and then you do your formal math proof. Nobody just dives on in. The pseudocode is our way of breaking down these big problems. So how would let me walk you through my thought process on this one. How would I get the 5 smallest numbers, or maybe the 5th smallest number, in a set of numbers? So I'm going to assume, and we can look into that. We have some kind of list L. It just has a whole bunch of numbers in it. Okay. How would I find the 5 smallest numbers, or the 5th smallest number in this list of numbers? Can I algorithmically find some way of doing it? There's a bunch of ways I could do. So what I might want to do is, what if I had the minimum? Min L will take the list and it'll tell me the smallest number in there, the index or location of smallest. Okay, so let's say min L gives me the location, what position in the list it is. So let's say, so let's do an example. 117, 92, -1, 4. Do I want more than that? I want more than that because so let's put 17 in there again, and 27. There you go. So what I want to play with some numbers first. My first thought on this is, okay, how do I find the fifth largest in here? Well, it's not the 1, it's not the -1, it's not the 4, that's 3 of them now. It's not the 17, it's going to be the other 17. Whichever one of the 17 is, if that's either the fifth largest or the fourth largest, that's either the fifth largest or the fourth largest. So the answer is going to be 17 in this case. The question is, how did I do that? I play with it myself. I figure out what I would do. My approach is, I figure out how do I do it? In this case, I'm sort of glancing at the list, but if this list had hundreds of elements, I would have to do something slightly different. So what do? I find the minimum element. It's right here. And then I get rid of it. Then I find the next minimum element now that that's gone. And I get rid of it. And I find the next minimum element, and I get rid of it. Then I find the next minimum element, and I get rid of it. And then I find the next minimum element, the fifth one, and that's what I return. That will do it. There's a bunch of ways you could have done. You could have sorted the list and then just get the fifth element. That would also work. There's a bunch of approaches you can take. So I would have, so let's say count is equal to 0. So I should say while count is less than, let's make it, should I make it 1 or 0? Let's make it a 1 to keep it simple for you guys. While count is less than 5, what am I doing? I'm going to IDX for index is equal to min of L move and notice I have this condition here is for this while loop is going to go over all of this thing here. I'm going to return. I've removed I've removed the 4 smallest, so now if I return the minimum of L now, it is the element that I'm looking for. That would do it, right? That's the kind of approach. You're just trying to play with an idea. It's not something formalized. It's not something like, oh, it has to look exactly this way. You're just breaking down a big problem and seeing if you can think about it in weird, wonderful ways. Okay, I'm going to check to see what kind of feedback or what kind of comments you guys have been giving me, because last time I talked about 2400 for a while. Okay, we have a Mac user, VirtualBox. Okay. Yeah, Bootcamp will take a lot of space. I'm assuming many of you are Mac users, and this is a great thing for you guys to be going back and forth on. If Janae has not given, did Janae give full instructions on you installing the Mac? If he did not, he should be posting that. A few times here. Okay, so no questions are not answered. Download virtual machines. Okay, yeah. Yeah. So if you're a Mac user, unfortunately, it was not my call. I kept on arguing with this particular point. We have to have one build our one system to build towards for all of our courses to make sure that it's consistent. And therefore, the Mac, it was a virtual box on a Mac is a workaround that makes sure that you can use both your Mac and you can use Windows. And we also had to make sure that all the lab machines also synced. So we had to have some kind of standard that everything goes to for your assignments. If you did your assignment in a different IDE than Visual Studio, if it doesn't work, you can't expect the TAs to have tried every single possible combination or IDE available on the market. So if you pass them code and it doesn't work, you get it works on my system philosophy, or it works on my system workaround, which we were trying to stop, essentially. So if it doesn't work on Visual Studio, we're going to say it doesn't work. And that's why you need the Mac version of it. Okay, why you need a virtual box, because the Visual Studio does not have C++ on the Mac for some unfathomable reason. All right. Other questions? Let's see. We had a whole slew of labs for this week. The labs are their own thing on CU Learn, in case you're wondering. Okay, remember this from lecture 2. Okay, great. Run Linux. Good luck then. Adib, yes, I have a Linux dual boot on my desktop, but my God, I learned to hate Linux. There should be instructions on Piazza for how to install VirtualBox. If there isn't, we need to work together. I cannot help with it because I don't have a Mac. So, oh, great! Emory Oracle website will instruct you. Great. So, other questions? What other things do people want to go over? It's been an hour, so I was gonna just see what you guys had. What kind of open questions you guys had, and then next time I will hopefully not go over 2400 at the start of it. David, Mac users or practitioners. Okay, I think we're fully in how to dual boot here. By the way, you're not going to have to compile anything for at least another week, simply because we're doing pseudocode right now. And I think we're also doing binary, hexadecimal, and decimal in the converting of the number notation. So we're going to be dealing with, on paper, how to program, not, how do you compile this thing? Because we're not looking at syntax. The syntax are something you have to learn, but that's not the thing that is translatable year after year after year. The algorithm, the ability to break down a big, nasty problem into an algorithm, methodically break it into some set of unambiguous steps, that's the thing that stays with you. And so we're going to be looking at binary hex and the like, just because it's necessary to look at it when you're doing C programming. You end up looking at this stuff. So you have to understand how things are being stored on the computer. But for the time being, you do not need your Visual Studio installed yet. Don't do what one student did in fall 2019, which is, I think it was November, when they freaked out that they needed to have an installed Visual Studio. Install it before then. But you got some time beforehand. And heck, if you do it right, you should make a flowchart or a pseudocode for how to install Visual Studio for practice on how to do pseudocode and how to do flowcharts. All right, do we have clock? It might be a useless variable, Stephen Shepard, for the bilingual clock. I haven't done the bilingual clock in a while, so that was somebody else's tutorial, not mine necessarily. So if you got the bilingual clock working, that's fantastic. I was doing the Pong one because I figured close enough. I just want you guys getting your feet wet when it comes to coding something without having to worry about, I have a compile error. Because when we hit C++, when we hit C later on, everyone's going to freak out about missing semicolons and stuff like that, and get frustrated. Uh, versus Scratch prevents you get to play around with things, and it doesn't just barf on you. So that's perfectly fine. That's great that you did that though. Pseudocode, provide pseudocode for the Pong game. Clock. Nope, pseudocode is for later on. Pseudocode, you'll be doing pseudocode for, I think, assignment 2. It's going to be things like, okay, find the range of values for a bunch of numbers. That's not the actual example, but that could be pseudocode, right? I give you a list of numbers, give me the range of values. Give me the standard deviation, or find out how many letter A's there are in this string of this set of characters. These are the kinds of things that you can do with pseudocode. It's not dependent on a language. Sound 1 and sound 2 were never used. Okay. All right. Does anybody have any additional questions? There's a lot of chatter going on, but at the same time, it's not necessarily for me to read. I would have to look into. Is Wednesday the assignment? And the video is saved. So if your lab is on Wednesday, you would submit your lab, whatever lab work you get accomplished. But we're not freaking out about that. The thing to freak out about, and I want to be very, very clear to freak out about this, the assignment due dates in the main course, those don't move around at all. So yeah, next Monday is assignment 1. So assignment 1, make sure you pass that in early. You can pass it in as many times as you want. You should actually have an unlimited number of times you can submit that file. So submit early, submit often. So if you're a minute late submitting it, we just grade the one beforehand. And what's due on Wednesday, presumably due, is the lab for some people. And it's not really due, it's do the lab, see how far you get, pass it in. And it's the Pong game, yeah. We're starting off a bit slow. You'll get the hang of things really, really quickly, everyone. I know this is a weird term, and if you're in first term at university, this is not the way you start. Normally, I'd have a lot more hand-holding, especially with quizzes and all this kind of stuff, because I would see you in class. I'd also like to find out how things are going with the quiz itself, because I just made a bunch of quizzes for 2400 on CU Learn versus on Poll Everywhere. But if you can take the Poll Everywhere quizzes and they work fine, let's stick with that. So yeah, it's very unique, unfortunately. I hate it. It plays to my every weakness. So you will see us and our smiling faces soon enough, but just not right now this term. All right. I think we're probably due. Okay, add some stuff to the Pong Lab. Oh, add whatever you want. The labs are free to play. Where's the ODR? What's the ODR for, though? A Scratch file is savable on your desktop. Yes, they are savable on your desktop. There was one part earlier in the video where I saved it to my desktop. You could save it, you could save a copy, and you can also save it to the desktop. The nearest quiz would be due a week after I originally released it. Right now, there's no quiz that's due at all. I would just want to practice. So right now, for the quiz, here is the quiz. Test 1, what do you think of the in-class quizzes? There is, I think, technically a wrong answer, but it doesn't matter if it's a wrong answer or not. It's not worth any points. So this is just a practice quiz, and then we have all these other quizzes for me to activate when we're going over them. I want to start opening those up, but I want to make sure that people can actually take those quizzes, obviously. So, if that makes sense. So please keep me informed on everyone got really panicked about doing the quizzes or being able to log into the quiz system. I want to make sure that that's still working and fine. If it is, I'm going to start loading them up. I'd also like to point out that since I cover so many classes and I've recorded most of my videos like in the summer, if there's a quiz that should be open and it's not open, fire off an email. Well, maybe not fire off an email. Send a Piazza post. That way other people know that there's a problem. So I can make sure I I enable it. It should be enabled beforehand, but there's so many moving pieces that there's easy enough for me to forget one. So just fire something off to me just to make sure that I enable the quiz for you so you can take it. If you can put comments in your submission, then absolutely, that's a perfectly fine place to put the comments for your game or how to play it. The quiz 01 should have been fixed by now, and if they're not fixed, I need to fix them again. But I went through all of quiz 0, fixing the due date, the dates. You may have taken an older version of it. They do for our lab class. You would submit the lab stuff that you do during that session, but not necessarily freak out about being late or anything like that. Just submit what you have. I don't want people spending the week working on the lab and not doing the assignment. And Mohammed, you can look at the rubric on that one, because for the life of me, I don't think I remember. I think it's 5%, but look at the course outline for that one. All right. I don't see other new questions yet, but I'll wait one more time. But I think we're going to be calling it quits on this one. Please reach out if there's anything else that's getting your way. I think there's going to be more concern when we start doing actual coding in C. And so I want to make sure that I can work with you either on an individual basis or as a group, and we can work through some of the problems. Dab away. All right. Are we good to go? All right, everyone. Thank you very much for listening. I will make sure this is meant to be open for you guys. That's what we have it for. So please come in with questions, whatever questions you have, and I'll try and answer it with all that stream. It's hard to keep up with them all. You can probably also, we could also make a Piazza post where you can pre-post your questions if that makes things easier to make sure you get an answer. All right. Thanks, everyone, and I will talk to you later. Cheers.